Welcome back to ArmanisMath. Today's focus is going to be on parametric relations and inverses. Parametric relations and inverses. As we discuss this topic here, you'll find out that this brings some memory of solve by substitution. So in a nutshell, if you wanted to know what exactly are we talking about here, the picture is this. Perhaps you have yourself a factory, a toys factory, and then in the factory you have raw materials coming in. Let's say they're X's. It takes about, let's say, 25 hours to drive to the factory. 25 hours. So raw materials could be threads, it could be cloth, it could be whatever that you need for producing these toys. Out comes the the output, or the number of toys. Sounds like we're talking about Christmas season here. And let's say that to produce this, you need about 30 hours. Okay? 30 hours for you to produce these toys in the factory. Okay, let's say 100 toys. 25 hours for the raw materials to arrive, and also for the outcome or the output or the Y's, you need 30 hours for that. So let's say that you're a top executive and you're not really interested in the number of hours. You just want to know what's coming in as raw materials and what's going to leave as number of toys. So you want to eliminate the T, the time involved in this. The first equation here was X in terms of the time, like it takes 25 hours for the raw materials to arrive. The second equation was it takes 30 hours to produce X number of toys. So there's two different equations here, and both of them involve the T, or the time. And let's say that you do not want the time anymore. So there is a way to do this just to give you X in terms of Y, without the need for time. You're going to eliminate the time. We're going to eliminate this T variable. Okay, first thing first is we're given here two functions. X equals T plus 1, Y equals T squared plus 2T's. The first thing they want to ask you is to construct a table that has some T values, some X, some Y's, and then finally some X and Y. So and they suggest values to you. They said, well, if you have T of -3, T of -2, all the way to 3, and you construct yourself a table in this manner, you have the T, which is given to you here, and then you have the X. Remember, the X is the raw materials, so you get an X, which is T plus 1, and if you take -3 plus 1 is going to give you a -2. And then you could also talk about it in terms of Y. The Y is the T squared, so you're going to take -3 squared, plus the 2 times -3, which is 9, minus 6, which is 3. And then finally they wanted you to have a column for the X's and Y's. So what X's did you get? Well, -2. What did you get is 3. That's basic construct of a table here. What's more important, though, is for us to eliminate. So we need to eliminate. We need to find a algebraic relation between X's and Y's. We do not want the T. We want to eliminate the T. And we're just going to spend a few minutes on that. We're going to get rid of the T. So let's see what the function is. I'm going to start with a very easy function, okay? I'm going to start with a very easy function. Let's say that your function is X equals T plus 3, and the Y equals, let's say, 2T's. This is just an example before I do the one in the textbook. Okay, so first of all, you need to isolate the T. You need to separate the T. And I also, while I'm doing this, I need to get a couple eyes on my on your guys's a couple eyes on the live chat and also on the live stream. Okay. So I want to eliminate the t. By the way, I was also on the live. If you clicked on the live, you could find me there. That's why I provide you the link. So to eliminate the t, I really have to separate this first one here. So this is equation number 1, equation number 2. I want to separate the t's in the first equation. By the way, it doesn't matter which one you pick. Just pick the easiest one. My easiest one right now is the t itself, the first one. So I'm going to say x equals t plus 3. And I'm going to say I'm going to subtract 3 from both sides. So t right now for me equals x minus 3. Is everything okay, guys? We cannot access stuff. It's okay. Can you access? Can you watch me here? Can you watch me here? Do you see this here? Okay, that's good. Okay, until I fix the issue. Okay. Apparently, some of you are able to. I'm able to see some of you on the live as well. So it's not a big deal. You could just again just look at watch me through here as well. Thank God we have more than one tool that we could use. So anyways, back to here. So now this becomes my t box, not x box, my t box. So you're gonna take the t box and you're gonna plug it into the second equation whenever you see t. Basically, believe it or not, we're solving by substitution here. So you're gonna say y equals let me actually write it down for you. Plug or substitute x minus 3 into the t of equation 2. That's what you're doing here. Okay. And this lesson has been recorded. Okay, this lesson has been recorded. And basically what I have here is, again, I have y equals 2 times the t, 2 times the x minus 3. Bear with me a second here, guys. And I just have to distribute. This is 2x minus 6, and I am done. This is it. This is my equation that does not have the t involved in it. It has a relationship between the x's and y's. Only x and y. Okay. Okay, guys. Once again, I am recording on the live stream, and I'm gonna post this afterwards. Just to recap what we've done thus far, let's go at the top here. I said this entire lesson is basically based on function, I should say, relations and inverses. And I started with given simple pictogram of the topic, which is, I said, a factory that has some toys coming in, materials for toys. Here's the pictogram here once again. So this is your factory. You have raw materials coming in, which is X's, and it takes about 25 hours for them to arrive to the factory, your toys factory. And then you also have the number of toys, which is the Y's, and it takes about 30 hours to produce these number of toys. The question to us was, are you able to only give me an equation that involves only the X's and Y's without the T, without the time involved? And that's the topic, kind of a 50,000 foot view of the topic today. We're going to eliminate this T. We do not want the T here. Okay? So that's why we went and took an example on what to do. And that example was, it was this one here. So we said the t, the first example, we said x equals t plus 3, and the y equals 2 t's, and we were able to pick one of them. I'll probably pick the easiest one to isolate the t, and I did isolate the t here. Once I isolate the t, I plug that t box into my second equation whenever I see a t, and I end up with this equation here. The final one does not have a t. There's no t's involved here. It's only x's and y's. All right. Go ahead, George. Of course, go ahead. Take care of that. Hopefully everything is fine. Okay, guys. So that's in terms of the first example that I gave. Now let's see the first example that they gave us. They gave us one that is linear and then the other was quadratic, and they want us to eliminate. Well, it's not a big deal. Okay, so I'm gonna walk you through this. We need to isolate the t again. So to isolate the t, x was equal to t plus 1. T plus 1. That's the example in the book. And then the y equals the t squared plus the 2t's. All right. And in this case, I again want to isolate the t. By the way, it's perfectly fine which one you choose to isolate. I'd probably choose the easiest one to do. So this is number 1, and this is number 2. I'm going to choose number 1, just easier for me to work with. So if I want to isolate the t for number 1, that's x equals t plus 1, and then I'm going to subtract the 1 from both sides, so t is going to equals to x minus 1. Okay, now this is my t box. My t box is going to be just like that. Now we're going to take this t box and plug it into whenever I see a t, into the second equation. Plug x minus 1 into second equation. And let's do that. I've got y equals, what's my t now? Well, it's x minus 1. That's what you came up with, twice squared plus 2 times x minus 1. So let's do some simple arithmetic here. There's a shortcut for this guy here, or you could use the FOIL, distribute the box to give you this item squared, okay? But I'm going to use shortcuts. You square the first term to use the same sign here, minus 2 times first times second. That's 2 times x is 2x times 1 is 2x. And then square the second item, which is 1. And for this guy, I'm just going to distribute. So I have a plus 2x minus 2. Don't forget the y equals that. So y equals this amount. I only have x squared. I've seen 2 x's minus 2 x's. They're gone. And I see negative 2 minus 1. That's a negative 1. So once again, we did arrive at an equation that has no, this has no t's involved. And that's what we want. All right? You don't want t's. You want to eliminate this parameter, which is the t. And I've given you a couple examples here. Okay, thumbs up if you're good, thumbs down, or maybe write something in the chat if you still need one more of this. Okay, let's see what's going on. Thumbs up, thumbs down, thumbs down. Okay, let's do another one then. Okay. And I'm actually going to do one that is you're probably going to see sometime soon. Okay. So let's say I've got I'm asked to eliminate the parameter in this example. Okay, eliminate the parameter. Okay, what we're after here is I have x equals, they're talking about t in this case, the t. X equals 2 t's, and y equals 3 t's minus 1. Okay? So we're asked to do that. So help me out a little bit here. After I label my equations here, here's 2. I need to get rid of the t's. What do you think is the first thing I need to do? What's the first step? That's true. And which one do you think I'm going to choose? They're equally, probably, I'm not sure. Which one would you like to choose? Number 1. Okay, anybody else has a different flavor? Remember, when number 1 you have to divide by 2. I'm just saying, it's not horrible, I'm just saying. You just have to divide by 2 if you want to. Number 2, you don't have to divide by 2. So, it doesn't matter which one you choose. I'm going to pick the straightforward one, so I'm going to work with number 2. So I'm going to take number 2 and say y equals 3t minus 1, so I have to add 1 to both sides. Remember, I'm trying to isolate the t's, so we're going to y plus 1 equals 3 t's. Well, in this case, I also have to divide by 3 anyways. So it wasn't really a shorter cut, I guess. The other one would also have done the same thing. But anyways, this would be a t equals y over 3 plus 1/3. Let's see if I actually took your guys's some of your guys' suggestion. Let's say if I want to do it using the first one, x equals 2 t's. And then you will divide by 2, t equals x divided by 2. A little bit, yeah. They're both fine. Anyways, so once you arrive here, you will take, let's pick one of them. Which guys, which one do you want me to pick? This here or this here? The A or the B? A or B? B. Okay, thank you. We'll take the B then. So let me. There's nothing wrong here. Just gonna hold on to this one. So I'm gonna take this guy and then put. Then I'm gonna plug. T equals x over 2 into number 2 in this case, right? You can't plug it into yourself. If you plug it into yourself, well, guess what? You're going to get the same equation back. So plug it into number 2. So I will basically come here and say y equals 3 times the t. And the t was x over 2 minus 1. Y equals 3 over 2x minus 1. And again, this one here, it shows you that you don't have any t's anymore. There is no t's. No t. Okay. I'm gonna be selective here, so inverses and relations. So this one is focused on the inverses and relations. We're gonna spend time here to basically go over the inverses of the function, like a function and its inverse, or sometimes it's a relation. So the definition: the order pair AB is in a relation, in a relation if and only if the order pair BA is in the inverse relation. Well, that's kind of this is what it says here. You have basically a you basically have at the top here. Do you think this is a function? Is A a function? Is the graph of A a function here? Does anybody know what did you use to figure this out? I mean, how did you know it's a function or not? You must have tested it somewhere, somehow. That's true. Vertical line test tells you this is a function here. Now, there is also something called, obviously, B is not a function, right? Because it fails the vertical line test. There is a horizontal line test. What the horizontal line test is used for in this case, it says here, the inverse of a relation is a function if and only if each horizontal line intersects the graph of the original in at most one point. I'm going to say this one more time. So how do you know that this is the inverse of this guy is a function? Well, the inverse is a function only if the graph is touched horizontally only one time. Okay, what does this mean? Well, let's see a graph. You have a graph that looks like this. And then you're going to use the horizontal line test. Anywhere on the graph, horizontal line test. If it passes, which does, it passes only one time, horizontal line test. It says here, the inverse of this is a function. If the original one passed the horizontal line test, then the inverse of this guy is going to be a function. Okay, let's take a picture of these, some of these items here. So here's an example here. Here's first number one here. It says, let's start very simple here. Is number one a function? Good. Now I'm going to use something else, which is called the vertical line test. I'm sorry, the horizontal line test. So I'm going to come horizontally and try to dissect number one. So it does pass here, it does pass here, and whatever you put the horizontal line test, it's going to pass. Horizontal line test. Okay. If it does pass it here in the original, when you do the inverse of this, the inverse is also going to be a function. So you know for sure this guy's a function because you did the vertical line test. This is a function. Okay. And if you, on top of it being a function, if you did the horizontal line test, you will find yourself looking at also an inverse of a function. The inverse is going to be also a function. There is more than one way to say and do this, but this method is kind of just graphically, and there's also another way graphically that you could tell. A question here: if we do the vertical line test and it passes, is it possible it may not be a function? Okay, so I guess the question Justin is asked: is it possible that it passes a vertical line test and the inverse is not a function? The answer to this particular question is right exactly at the above here. This was an example here. This passes the vertical line test. It's a function. The inverse of it is not a function. Okay? The inverse is not a function. But it does pass the vertical line test. Yeah. So anyways, some of these here are, for example, number one, it says, and 4, number 1 and 4, they do pass the vertical line test. But number one, particularly if you do the inverse of number one, they're asking if this could be a function or not. If it is a function, then we call this a one-to-one function. So here's another definition. I don't want to bog you with definitions. We're going to do some other stuff that makes it a little bit easier for us to understand. But hang around with me here for a second. This one says if f is a one-to-one function with a domain D and range R, the inverse function f, or notated f inverse, and this is the way you write down the inverse, f inverse of x. This is not just 1 over f, just f inverse of x. Then the f inverse of x is also going to be is a function with a domain R and range of domain with a domain R. Oh, that's not right. With a domain D and range of R defined by I guess they're trying to tell you AB is BA. So the domain of the other becomes the range, and the range becomes the domain for the inverse function. As I said, I'm going to show you a little bit easier way to find out. So the first method to find out if you have an inverse function is to do it algebraically. Okay, the first method is to do it algebraically, and we're going to spend time here. I'll give you an easier example to start with, but now we're going to, there's 3 different methods to find the inverse, 3 different methods. One of them is algebraically. That's method number 1. We're going to spend time on this one right now. Okay, method number 1. So I'm going to give you an easy example to start with. Let's say I have my function is, by the way, if you've taken notes, which you should be, I have 3 steps for this, 3 easy steps for finding the inverse of a function algebraically. So f of x is going to be x plus 8. And let's find the inverse of this function. So number 1, you got to put this equation in terms of y. Y equals x plus 8. Remember, f of x is y to us. That's number 1. Number 2, you replace x's and y's. You replace x's and y's. So your x becomes a y and your y becomes an x. So you might want to put this picture here next to you, x's and y's. This is f of x becomes y. That's number 1. Number 2 is you replace x with y. And number 3, you solve for this new y. So I'm going to solve for y. I'm going to subtract 8 from both sides, which will give you y equals x minus 8. Once you're here, all what you have to do in the last step is actually, you could label it as step 4, or you could not label it. It's just simple. You replace this y now with f inverse of x, and that becomes your inverse function. What did I do here? Well, first step is obviously to make the f of x a y, right? And then you would switch the x's and y's, solve for, I'm going to put it here for you, solve for your new y, and finally you just replace this y with f inverse of x. This means that you have arrived to your inverse function. Okay, let's take another easy example before we take a look at the books. Find the inverse of this function. Let's say that I'm gonna give you f of x is 3x minus 6. Okay, 3x minus 6. What's the first step you think I should do? What's the first step? change f of x to y. So that's going to be a y equals 3x minus 6. Step number 2. Turn it into y. Step number 2, exactly. You swap the x's and y's. Step number 2, swap x's and y's. So every x becomes a y, every y becomes an x. This is x equals 3y minus 6. And what do you think the third step is? Sure, or basically you're trying to solve for this y. You want to isolate the y. So you said add 6 to both sides. So I'm going to add 6, and obviously later on you're going to divide by 3. So you are looking at x plus 6 equals 3y. And then what do you think I'm going to do now? Don't wait for your friends. You tell me in the chat, you show me on your whiteboard, you divide by 3. Everyone is getting divided by 3. And it looks like it's a 1/3 x plus 2. Okay. What's step number 4? Which is the easiest one there is. Yep, that's it. And don't forget the inverse, right? So it's going to be f inverse. That -1 at the top here. If inverse or the inverse of this function is 1/3 x plus 2. 1/3 x plus 2. All right. Now some of them are kind of doable like this, pretty straightforward. Another one, which is the text is proposing, and I'm gonna do it in its own space, which is this one here. So we're given a function that is where is it? We're given a function that we're asked to find f of x again. So find f inverse, and we're given f of x equals x divided by x plus 1. So in this case, they wanted me to obviously follow the same 4 steps algebraically, and I have to change that to y equals x over x plus 1. What's the second step, you guys? Somebody help me out. What's the second step? Swap the x's and y's. So it becomes x equals y over y plus 1. Y over y plus 1. What kind of y is that? All right. And we basically have to cross multiply. So I'm gonna that's step number 3, solve for y. So y, remember there's a 1 here, cross multiply. Y times 1 is y. X times y plus 1. Okay. And I just have to distribute. So the x, so the y becomes xy plus x. Xy plus x, see that? And I'm just going to have to subtract the y's from both sides. Minus y, minus y. And at the same time, you could also add the x's, but let's just wait one more step. Or subtract the x's, I should say. 0 equals xy minus y plus x. Let's take this x on the other side. So it's going to be a negative x equals xy minus y. And let's take a common factor here. The y is going to be common between these two guys. Open parentheses, x minus 1, and I do have a negative x here. Then if I wanted the y by itself, you just have to divide by x minus 1. Both sides. So basically I have a y equals negative x divided by x minus 1. That is also what they went and did is another extra step. It was kind of cosmetics, I should say. They multiply top and bottom by negative 1. They multiply top and bottom by negative 1, and that gave me yeah, I'm gonna go over this again. Y equals, I have an x divided by 1 minus x. So this should give us the final answer, which is step number 4, is to replace this guy with the inverse, x divided by 1 minus x. Okay, so let's see. I don't blame you. It's just a little bit convoluted here, but let's take a look here. Those who are asking, it was not straight. So I was given, and let's take a look actually the work here. So I was given f of x. I changed every x with y, and then I cross multiply. Tell me if you're good thus far. When we cross multiplied, were you good thus far? Do you know what we did here? Sure. So this one here, I have x, let me use a different color, y times 1, it's going to give me the y, and x times these guys here. So x times y plus 1. Are we good? Oh, you have to have an equal sign. To cross multiply, you have to have an equal sign. So let's say x over 3, 5 over 9. You've got to have an equal sign, obviously. Yeah. And if there's nothing here, you could put 1. You could make a fraction yourself. You have to have an equal sign to cross multiply. So 5 times 1 is 5. X times 9 is 9x. Okay, are we good with cross multiplying? Are we good with cross multiplying? So we can move on. I need some feedback. Remember, you also could use a whiteboard. Good. So now we just, after cross multiply, this is what you get. A little bit when it comes down here. So remember, the goal is to isolate the y's. There's multiple ways you could go about this, by the way. I mean, I could, but that's what they choose to do here. So subtract the y from both sides. You're going to end up with 0 equals xy minus the y that you just subtracted plus the x that is existing here. Well, then you take the negative, then you take the x to the other side. Sure, give me a sec. Take the x to the negative side, it becomes a negative x. And then remember that you need to take a common factor. You need to take out the y. And then you divide by this common factor, x minus 1. They did something cosmetic here, which is negative 1, top and bottom. Basically, it did not change the value of it. It just makes it look a little bit better. So this became x divided by 1 minus x, which is the inverse of that function. So let's see if we can come up with another one here. Okay. why don't we do another one here? Okay, find the inverse of this function. Find the inverse of f of x equals square root of x minus 3. By the way, is there any limitation for this? Is there any limitation for domain here? Can somebody tell me? Is there any limitation for domain? Am I restricted in any way in my domain here? All right. Exactly. I don't want that. So how do you write that in interval notation? How would you write your domain for the original function in interval notation? Come on, guys. Come on. Put that domain in interval notation. Well, hello. Where are you? Oh my gosh. Don't be shy. Give me the domain. I am not gonna relent. Three to this. So you want more than 3? That is true. 3 to this. So keep that in mind, okay? So 3 to that, 3 to infinity. So basically you're saying you can't have less than 3, which is true. I could have 3. That's why including the 3. So anyways. Okay, Derek, welcome back. Over here, let's say that I wanted to inverse. So the first step is to do what? To help me out, please. First step to do what? I need more of you to work. If you're asking for an additional example, I need you to help me out. You change or you make this guy a y equals square root of x minus 3. You change, I'm not sure if you want to call this a step or not, but change this guy now into the x equals square root of y minus 3. And in this case, you really have to solve for, well, you got to solve for y. So you solve for y, you basically have to square the square root to get rid of it, right? So if you square that, it's going to give you x squared equals y minus 3. Yes? Yo-yo. Are you with me? Are you with me or without? Ha ha. Come on, troops. So y will be equal to, you could add the 3 to both sides. I mean, x squared plus 3 equals your y, or y equals that amount. So y equals x squared plus 3. And that's number 4. You're going to just replace that with f inverse. F inverse is going to be x squared plus 3. x squared plus 3. Okay? We good? Let me introduce two other ways, just for the time frame that we have. Introduce two other ways to find out if we have an inverse. Obviously, yes, and that's why we're recording this video, and also we're gonna have some homework as well on that. So the second item I want to show you. So the first one was what? The first one was to tell if you have an inverse by graphing. Here's the second one. The second one's pretty easy, pretty easy. The second one is this. You could tell graphically if you have an inverse. If and only if you're able to reflect your graph on the y equals x. By the way, the y equals x line is a 45-degree line. So if you have a graph like this, like function here, the blue one here, and you have y equals x line, the 45-degree angle line, and if you're able to reflect it over that line, let's say that you've seen the graph and it's reflected over the y equals x, and it's the exact replica, then you could confirm that you're actually looking at a function that has an inverse function. So let's take a look at some of these graphs here. Here's the first one. So they give us this little squiggly thing, which looks like a cubic function here. And they give us the red line, y equals x line. Okay? And all of a sudden I see it reflected. So that's why you could conclude, once you see pictures like that, that these two functions are inverses. This guy is the inverse of that guy here. So inverse. By the way, it's vice versa. This is the inverse of that, and also the blue is the inverse of the black. It goes both ways. Okay, that's probably the easiest. Do you agree? Looking at a graph, you have to look at the y equals x. If it's reflected over the y equals x and it's a replica, then you just conclude that these both functions are inverses of each other. As simple as that. So first of all was algebraically, and the second, we've taken 3 examples of algebraically. The second was graphically, and I don't really think that we need some examples, but if you do, then I would probably use Desmos to help you with that, but should be straightforward for graphing. Okay. The third one, which we kind of covered half of it almost. The third method, which uses the idea of the composition. So this is a third method. The first was algebraically, the second was graphically, and the third was this one here. You actually use the composition. So if you did a composition of two functions, f of g of x, for example, and you end up with x, and then you do the opposite composition, which is g of f of x, and you end up with, this is a curve here, it's not a straight line, g of f of x equals x, then you would know that g and f, or f and g, are inverses. Of each other. Okay? So I'm going to start again with a simple example. So let's start with I'm going to start with a simple example. Let's say my f of x equals let's say I have my f of x equals x plus 4, and the g of x is I'm just gonna say let's say x minus 5. Okay, I just made this up. So we got two functions here. We're asked if these two are inverses. Well, let's see. If f of g of x equals x, let's see if that is true. And I have, by the way, I have an equal sign here. We're testing this. We're not sure yet. So let's see that. So I've got f of g of x. Somebody help me with the composition. What do I start with? What's my starting point here? G, that's true. So I'm going to take G the way it is, the G box, I guess, and put that whenever you see x into your f function. So I'm going to take this and plug it into my f function, which is going to give me, so f of x minus 5 equals what? Well, it's going to be x minus 5 plus the 4. How much is x minus 5 plus 4? X minus 5 plus 4. How much is that, you guys? Okay, x minus 1. Well, I really don't have to go further here. I'm only using the fact that f of g of x equals x. Well, it doesn't. So I shouldn't even test the other side, right? So I'm just going to have to stop there. This has to equal x. This does not equal x. So I just pause. So I could tell right off the bat f and g are not inverses. I don't have to test the other side. If the first side fails, the other side, even if the other side is true, becomes x. That doesn't help me. So that's one issue. Okay, that's a quick one for you to check. Now let's check if there is actually one that works. So they gave us an example of something that that works. Okay, so let's take a look at what they have here. Let's take a look at the example that they gave us, and let's do it. It says here that they gave us f of x is x cubed plus 1, and g of x equals the cubic root of x minus 1. And we're asked to see if these two guys are inverses. Okay, so the first thing I'm going to do, f of g of x. Hopefully, that's going to equal to, we're not sure, to x. If that is equal to x, I have to also test the other side to see if it's equal to x. So let's test this out. So I'm going to start with g, as you told me the other time. So f of, I'm going to put the g itself, the cubic root of x minus 1, which is going to be the cubic root of x minus 1 cubed. What? Yep, that's what it's here. X minus 1. This is a cubic here. So cubic root. That's a cube here. Of cubes. Cubes and cubic root going to go away. Right? And don't forget there's a plus 1 here, by the way. So cubic root are going to go away. By the way, the cubic root is 1/3 as the exponent. And this is 3. 3 times 1/3 is 1, and that's why they disappear. So anyways, that's going to give you just an x. Do you see that, you guys, or not? Good. Now let's do the other way. Don't be satisfied with one direction. There has to be both directions. Now we have to test the other side, which is g of f of x, to see if that is going to equal to 0. To equals to x. So we're testing. We're not sure. Okay, let's do it. So I'm going to take the f of x, which was x cubed. So I'm going to do x cubed plus 1 and put that into the g function. So basically I'm going to have to come to the g function, which is the cubic root of x cubed minus plus 1, and then there's a negative 1 from the function itself, from the g function. Okay, well, guess what? The ones are going to cancel, leaving you with the cubic root of x cubed. Well, guess what? That's going to equal to x. So because it's equal to x, because of g of x equals to x and f of x equals to x, then guess what? These two functions are inverses. So then, or therefore, f and g of x are inverses. Of each other. Inverses of each other, or of one another. Of one another. Wait, where did you get the 1/3 from again? 1/3. Oh, the 1/3. So the 1/3 was my comment on why was the cubic root cancelled. So let me try to put it on this side here. I could go only to the right side. Let's just spend time here. I'm glad you asked. So let's say I have a x squared. Well, x squared is this square root. There's obviously a hidden 2 here, right? This is exactly the same as x raised to the 1/2. So the square root is a power, is an exponent, but a fraction exponent. The square root is a 1/2. The cubic root is 1/3. The 4th root is 1/4. The 5th root is 1/5. And if you raised it to a second power, so if you said, for example, x to the second power, what you're saying is 1/2 times 2, which is just 1. Okay. I'm going to pause here. I'm going to conclude the lesson here. Take a look at the homework, but I'm concluding the lesson here. Let's chat a little bit about homework, and we'll see you on the other side. The other side of the mountain, the other side of the mountain, the other side of the mountain.